Hi everyone, so let's do today's daily lit code challenge question. It is Friday, happy Friday TGIF, and it's 10:05 p.m. So I'll just create a 20 minutes timer, try to solve within 20 minutes, okay? Just checking if it is still here. Streaming. So okay, let's read the question. 3254, find the power of k size subarrays 1. Okay, power of k size subarrays. You are given an array of integers norms. uh, you are given an array of integer norms of length and a positive integer k. Okay, so I'm given an array of positive integers, so these are all array of this integers, not positive or negative. Okay, and length of n and positive integer k. The power of an array is defined as its maximum element if all of its elements are consecutive and sorted in ascending order, -1 otherwise. You need to find the power of all subarrays. You need to find the power of all subarrays of nums of size k. Return an integer array results of size n minus k plus 1, where results I is the power of nums I plus k minus 1. What does this mean? I still don't understand the question. It's maximum power of k size subarrays. K size 3. So it means 3. Size is 3, right? And maximum element if all of its elements are consecutive, 1, 2, 3. So what is the maximum element? 3, right? So it means 3 and 2, 3, 4. What is the maximum element? 4 and 3, 4, 3. This is not consecutive, right? These elements are is not consecutive, so it will be -1 and 3, 4, 3, 4, 3, 2. This is also not consecutive, so it will be -1 and 3 to 5. It is also not consecutive, so it will be -1. Okay, so that's it. You need to find the power of all subarrays of norms of size k. All subarrays of norms of size k. So I need to find power of all subarrays. Nice. Okay, I can do that. Return an integer array results of size n minus k plus 1, where results I is the power of. Nice. It is not so hard. I guess this question I can do within 20 minutes. It looks simply straightforward. So I don't want that. So the size is 4, right? So I could just start from, I could just look at these elements. This is not in ascending order. I mean, this is not in ascending order, right? So since this is not in ascending order, I guess since this is not in ascending order, and this is also not in ascending order, so it will be -1 obviously. But how can I optimize it? Because the brute force solution is to look at all the array with the size of window 4, right? So first of all, look at this window, then this window, then this window. If but we have to look at all window and see if the elements are consecutive or not, and if it is sorted in ascending order or not. So it means that yeah, I'm just trying to think of optimal solution. Okay, let's look at optimal solution so that I don't have to check for all the windows, because if I have to check for all the windows, then what is the then my just think about it. I have to check about this, then it will be like O of n. It will be like O of n divided by k, and since k is constant, so it will be like not O of n divided by k actually. So if this is of size n, and if I have to do if I have to look at all consecutive windows, then oh yeah, it is O of n, I think, right? Or no? Oh no, I think it is O of n times k, because it's like for every element I had to look for k elements for all elements. So it will be O of n times k. Yeah, this is right. Time complexity will be O of n times k. Yeah, I think so. This is the time complexity, right? What does times mean? Like 4 times 3. What does it mean? It just means that 4 appears 3 times, isn't it? So 4 appears 3 times. That means 4 times 3. Yeah, I'm just trying to know what times mean. What does multiply mean? Multiply means that, right? 4 times 3 means 4 has occurred 3 times. 4 plus 4 plus 4 is equal. It means 4 times 3. So here also, uh, for every element, so so n will occur. So I since I have to look at all 3 elements for, suppose k is 3, okay, then I'll for and suppose this is 1 2 3 4 5 6 and 7. So it's like for all the elements, which is n like almost for all elements. I mean, I can only go until this 5 though, n minus k, but it is still n minus k is like n, right? So I mean, so it means for all elements, for first one, there will be 3 times, right? And then for the second element there will be 3 times. So how many 3 will be repeated? So I will have to, it will be repeated n times. So that is why the answer is k times n, because I will have to run through 3 elements n times. So that is why answer is k times n. Time complexity is k times n. Yeah, 3 elements, 3 elements, 3 elements, 3 elements. Okay, so besides this, what else? What else? What else? Oh yeah, I was talking about how can I optimize this, right? So I don't want to do it k if k times n, because if I'm looking at one sliding window, then maybe it should be, yeah, I think that there is some optimal. Okay, so let me first think of some examples, some scenarios. So 1 2 3 4 5 6 7, and so it will always be so I think that this holds something. This, since elements are consecutive and sorted in ascending order, that is the criteria. So I think that this holds some some this, because of this logic we can optimize, I think. Yeah, actually, because if the first 3 elements, if we know that, okay, the first 3 elements each in ascending order and consecutive, then obviously whatever we get, whatever maximum number we get from the first four numbers, we can just look at another, right? We don't have to go through all these numbers again. So if we just look at all the numbers one time only, then it will be O of n only, it will not be O of n times k. Yeah, 1 2 1 2 3 4 and then 5. So whatever is the maximum from the previous previous element, so I'm just thinking that here k is equal to 4. Okay, so whatever the previous four elements maximum is, suppose if it is 4, and if this is not equal to 4 plus 1, then it means so what I do is, first of all look at the first four elements and then if find the maximum size. Maximum is 4, and the next element needs to be 4 comma 5. If it is not, then it will be minus 1. Okay, and then since the previous one is minus 1, so since it shows that the previous four elements were not conjugative, and this shows that these four elements are not conjugative and in ascending order, right? So it means that so what I'm thinking is, so suppose previous four elements are like this: 1 2 3 4 or 5. Suppose if this is like 2. Okay, suppose these are the previous four elements, which is written as minus 1. But when I put this into account, then my four elements, they are in conjugative order, so I cannot just look at the previous four elements value and decide if if this batch of four elements are the one or not. Actually, can I just do sum? If I do sum, then maybe that is easier, right? If I can I just do sum, like 2 plus 3 plus 4 plus 5. If I do mathematics in every so if this is 5, then for this, yeah, I think actually the sum works better, because if I know that okay, this is the element 5, then for the last four elements to be like that, it should be like 5 plus 4 plus 3 plus 2, right? The sum must be 5 4 9 10 13 14, and I can just calculate the running sum throughout. I think this is the best idea actually. So for example, if this is 1 2 3 4 5, then what I could do is, for the first four elements, I can just start from here. Okay, oh, but k is 3 here, right? So I will just start from here. Okay, I'll just say that this is the current 3, and my running sum will also have something. Okay, so running sum is 1 plus 2 plus 3 3 4 5 6, right? And if the running sum is 3 4 5 6, and I can just calculate, right? If it is 3, then I'll know that okay, this would be there must be some formula, and if it is equal, then I will just put it as 3. If it is not, then sorry. So next element will be this, and this is s, and I'll also have some running sum, right? I can just do from this element to this element. When I go, I can just do minus 1, this first element, plus 4. Okay. So running, yeah. So running sum, I can just do previous sum. So running sum will be running sum minus first element plus current. Okay. And I need to update first element every time. Oh yeah, that is also tricky, because if it is 1 2 3, oh, that is not tricky, I guess. Or is it? No, first element I don't have to keep. I can just keep track of actually. I can just say that okay, this is I, and then, or this is a current, and I can just say that first element should also have some index, so first element is here. So when I do this, then first element also I can just um, increment, so this will always be for my first element, and when I increment my current, my first element should also increment next. So I should do -2 here. Okay, yeah, this looks good. So this is how I'll calculate running sum. And now I just need a formula, I think, then formula to know. So if I have any number, so if my current number is, so this is the question, right? If my current number is 4, and how to determine the 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 expected sum. So sum for last k elements, so it should be 4 plus 3 plus 2, right? So how to determine this sum? There must be some formula. There is a formula for natural elements, right? N is equal to n plus 1 divided by 2, but that is for 1 to that is for when it starts from 1 till n. But I just want from n back from n to not 1, but I just want from n back to just 1 some number. Oh yeah, but how I can do that is I can just, so suppose if some number is uh, each m, okay, then it will be like m into n plus 1 divided by 2. So this will be from 1 to m, and this will be from 1 to n, right? So suppose if this is x, and suppose if this is y, then from m to n will be x minus y, isn't it? Yay! Yeah, yes, that is true. So 1 2 1 2 3 4 5. So if I have sum from 1 to 3 and 1 2 3 4 5, then it will just be 1 2 3 4 5, I guess. Yeah. So let's just look at the simple example. So 3 4 5 6. 6 minus 2 plus 1 2. 2 plus 1 3. Let's look at bigger example. 6 4 10, right? And suppose if I want the last two elements, it means 2 plus 1 3. So 10 minus 3 is 7. Yay! Yes. Yeah, this looks good actually. So if this is an element, and if I want last two elements, then it should be 4 minus 2. If this is n, then it should be n minus k. So 4 minus 2 is 2. Yeah, I mean, if current is 4 and current minus k, So if current is 4 and I want sum of last two elements, then it should be 4 minus 2 is 2. What if suppose like 1 2 3 4 5 6? So what if I want 6 last 1 2 3 4 elements, then it will be 6 minus 4. each 2. Yeah, this looks good. So I need to find the first two elements sum and subtract from. Yeah, actually this works. Okay, then first of all let's write that function. Find sum of, yeah, it's still streaming. I'm just waiting this because it's cold. So find sum of last k elements. Find sum of last k numbers. So this is equal to, okay, let's write this logic later. Okay, first should I write this logic now or later? It's, yeah, I can write this logic now actually. Find sum of last k number. So it means that if I am given a number current C, then find sum from 1 to n. So C minus find sum from 1 to n for C minus k, right? Yeah, that's what, isn't it? So this is this is what. Yeah, this would work, right? This is what we did. So first of all I will find sum from 1 to 4, and then I will find sum from 1 to 2, and then subtract this minus this. N minus k will give me the first few numbers. Yeah, I'm just trying to confirm if this logic is clear or not. Yeah, it would be. So from, if from 1 to 10 numbers are there, then if I want to find the last 5 numbers, then I will just delete from. If I want to find the last 7 numbers, then I have to delete the sum of first 3 numbers. So first of all find the sum of whole, and then find the sum of 3. 10 minus 7 is 3. Yeah, this looks perfect. Now let's look at the main logic. Let's look at the main logic now. What is the main logic? So for the main logic, I have to define let running sum. It should be something, and then let current is equal to something, and let what? Let first element. Let first element. Yeah, first element should be something, right? And then I'll just have to look from until it is last. So while current is less than the last element, norms dot length, right? So until it reaches here, we should keep on continuing. We should keep on doing it. So first of all, I think current should be placed in the k, wherever k is. So if k is 3, then it should be placed in 0, 1, 2. This is the first one, right? So current should be in the first k minus 1, right? So 0, 1, 2, this is the first 3 elements. So if current is here, then first element should be at 0, and my running sum should be running sum in the beginning. Running sum will be running sum will be 0, and then I just need to find running sum, from 1 till 3. So let I is equal to 0, I is less than k, I plus plus, right? Because I want to do from 0 1 2. So my running sum will be running sum plus is equal to norms I. So this will give my first running sum, and then once I have the running sum, now it is the same logic, right? Now I'll just find the expected. So this is my main logic. So what is the expected? Find sum of last k numbers, and this will be my current index. So norms in current index. So find sum of last k numbers for the current index, right? And what is the sum of the last k numbers? Expected sum. So this is expected sum, right? And actually I can also do let result array, and if expected sum is that, if expected sum, so only if expected sum, if it is equal to running sum, then I will have to push what to the result. If it is equal, then I'll have to push the current number, right? Because that is the biggest number. But if it is not, then I will have to push -1. Okay. And what else? So yeah, so this is it is done for this one, right? So I will have to increment c now. Current should be now current index plus plus. I'll go to another number, and first also should be, yeah, current index. Now it will go to another number. So when current index goes to another number, running sum should also be it should also be, so running sum will now be equal to running sum minus norms first element index plus norms current index. Okay, since it has increased, and then first element index should also increase now after calculating running sum. Yeah, so this is it, and at last return result. Should I write function here first? Function n times. Yay! Oh, 853 test case passed though. So here it should be -1, but here it is returning 6. This is bad. Why did it return 6? I don't know. It returned 6 for this one. 1, 2, 3, 4, 5, 6, 7. For the last 4. This one. 1, 2, 3, 4. For this one. Why did it return 6? Because for that element, because for this element, It cannot be equal to running sum, right? Because running sum would be like too much here for this one. 1 2 3 4 running sum would be like 90 100 something, and the expected sum would be 6543. 6543, yeah. So what should I, okay, so this is for the wrong answer, right? So nums, so let's look at the, change the test result, test case, saying the nums is this and k is equal to 3 only. Okay, and what is it returning for 6? Oh, it is returning true here. Expected is 15, right? 6 6 5 4 3 6 5 4 6 5 11 15. Yeah, expected is returning true, but why is running sum returning wrong? Running sum is equal to running sum minus nums first element index plus nums current index. Is this not right? This is how it should be, right? Running sum. So running sum, how did it become 15 here? So it was 101 before. It is interesting. So how did it become from 101 running sum to 15? So this was my 1 2 3. This was my running sum. Oh, 6 6 12 13 14 15. Actually, oh no, I cannot just look at the sum. I should also see if it is in the increasing order or not. 6 6 12 13 14 15. Yeah, what? I did not take that into consideration. I cannot just do last four numbers, right? See here, look at this. Sum is 15, but it is not in the, it is not in ascending order. It is, but it's still only two case, only two test case failed, even for my bad logic. That is so funny. But anyway, what I mean is, what I mean is this, my whole logic is wrong. Wow, I did not even think about like if this, yeah. So note to myself, whenever I create some logic, whenever I think of some solution, always please double check if that is, that works, that solution is really foolproof. Because see, only if it is, yeah. But how to make sure that the last four elements, they are, oh my god, these are such a linear solution. But how to make sure that that the last three elements, they are in the ascending order and they are consecutive or not? Mm, 654. You know, it could have been 654. I mean 654 and 663. It just returns the same sum. So even if they are not consecutive, it can return the same sum. So how to determine if they are consecutive or not? And I cannot just check the last number, I have to check all the numbers, because for some it can just be one different, like suppose if this is the suppose there are like so many numbers, okay, like 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so this, suppose this is the section that we are looking at, and here it might be little different here only 4. So see, the sum will still be the same, but since only this is changed, so I cannot just look at like last few numbers. I have to look at all the numbers and check and make sure that all number before this number, they are, they are consecutive. And so how to check that, like how can I do it optimally, how can I do that in linear time? So I keep some flag where it says okay, it is still maybe, so maybe if 1 to 3 is here, then maybe when I'm increasing here 4, maybe I will know at that time. Oh no, I just want to look at the solution. Okay, I'm so sorry guys, because I'm too, like, it's already 10:41 p.m. It doesn't feel like 10:41 p.m. though. I think it's because it is Friday, so I'm really really fresh. If you look at the videos that I made during like this week, yesterday, day before yesterday, then I look so tired, right? But today I'm very fresh because it is Friday. Brute force solution, sliding with the DQ, and optimized via counter. Oh, okay. I can do that, right? I can just create a count which is consecutive. What is the last 4 consecutive numbers? Yeah, I think this solution is fine, but I can just, actually in editorial section I just see one thing, consecutive count, and that like triggered my brain thinking about maybe I can keep the last consecutive counts, whenever I'm moving, I can just say okay, the last consecutive counts, they are last for, yeah, actually I can do that, I think. So I can just create last consecutive count, so whenever I'm here at this point, so last consecutive count is 4. Whenever I go here, then no, they are not, they will not be, like it will be 0, and then if I reach here, then it will be something. When I reach here, then it will be something, so something like that, it should keep track of consecutive elements. So 1 plus 1 2, consecutive count is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is not 3, so reset consecutive count to 1. 3 plus 1 is not 2, so reset consecutive count to 1. Reset consecutive count to 1. So yeah, this is such a good idea. I love this idea. This is very very nice solution. What are they doing here? In approach to sliding window with DQ. I don't know. We can use the sliding window to avoid rechecking the entire subarray from scratch. We use a dequeue to store the indices of the elements in the valid sequence. We'll maintain a window of size k to slide through the array, focusing on two aspects: keeping track of the current valid window and ensuring the consecutive property holds. As we move to a new element, we first check if it breaks the consecutive sequence with the last inserted element in the dequeue. If it does, then we invalidate the entire window and clear the dequeue. Otherwise, we add the current elements index to the dequeue. So it will be like remove elements that are out of the window, remove the elements, and then remove elements that are out of the window, check if current elements break the consecutive, and sorted condition, add current element index to the dequeue. Check if the window is of the size k and update the result. So here time complexity is O of 1, but space complexity will also be O of k, because we are adding every time we are keeping the size of k. Yeah, this is also a good solution, but I like the another solution. Wow, just keeping consecutive count every time. And yeah, like when I look at the solution, it makes me think, why did I not arrive to the solution? Maybe because I think very, nor I don't think simply. I think very like, oh wow, the solution must be very hard, it must be very very complex. So I just look at things in a complex way. I think I should just look at things more simply, and I think I'll start looking at things simply if I create more examples and run through those examples. But here also I try to run through examples, but when I created new example, my mind started overloading more, thinking of more situations, more cases. But yeah, I think instead of overloading, I should just focus on the example that I created and run through that example and create another example, run through that example. Yeah, I should learn to manage my thoughts. Yeah. Hmm. Remove elements that are out of the window. Check if current element breaks the consecutive sorted condition. What I did not understand here though is, why do we need to keep the whole elements in an array? So each time we move the array, we don't want to check all the elements, right? That is why they are using dequeue. If this is the first four elements, then this will be the last four. This will be the four elements. First one will go and last one will come in. Window of size k to slide through the array, focusing on two aspects: keeping track of the current valid window and ensuring the consecutive property holds. As we move to the next new element, we first check if it breaks the consecutive sequence with the last inserted element in the dequeue. If it does, we invalidate the entire window and clear the dequeue. Otherwise, we add the current elements index to the dequeue. So first three element 3 4 3, this is breaking. 4 3 2, this will also break. 3, oh yeah, keeping the size is good because if it is 1 2 3 3 4 3 3 4 3, right? So the conjugative property is not there, so 4 3 2. For 4 3 2, the conjugative property is not there. 1 2 3 3 4 3, the conjugative property has gone. 4 3 2, conjugative property is not there. So I mean here, so 1 2 3 conjugative property is there. 2 3 4. Let's look at this example only. So 1 5 5 1 5 90 10 90. Let's not look at this example, or let's look. Okay, let's look. 1 5 5 5 5 90, conjugate property does not hold. 5 90 91, conjugate property does not hold. But yeah, so actually the conjugative property holds here, and here conjugate property holds. So now the size is 3, and conjugative properties also holds for this one. Actually, yeah, I should have thought about the solution more. Um, so whenever I think the main takeaway from this video is, whenever I think about, whenever I feel like I have some doubt on something, then I should be clear on the question that I am having. Because yeah, and I think there are main two takeaways. First is just make sure that your solution is foolproof in the beginning, because at the end, if I find out if my solution does not work, then at the time, just going back to the solution and refining the solution takes much more mental energy. But if I just find that there is a problem at the time only, then it will be easier for me to fix at the time only. That is first thing. Just make sure that the solution works, be clear. And another thing is, and the biggest thing is, if I'm confused about something, then just make sure, because this feeling of confusion, it comes from your intuition, right? Like that something is not working, something is not wrong, but you are not even sure. So I need to follow that intuition, and then make sure, and then voice it out, that okay, this is the point, this is where I am confused at. So if I can only know where I am confused at, then I'll find the fix for that confusion, right? First of all, I should know what problem I am having in my mind. Then I can think of solution. Because normally what happens is, I feel like there's some problem, but I do not even know what problem. But it's just about a feeling. So what I mean is, I should be clear what I'm feeling, what exactly is problematic, what exactly I'm trying to, what exactly is the thing that I'm finding it hard. So there should be a question, there should always be a clear question whenever I'm trying to solve anything. So that, yeah, so whenever I'm like solving lead code, whenever I'm talking, right, it should always be towards finding an answer to a question that I have in my heart. But if I do not know what question I am having, then what am I even searching, what am I even trying to solve, what am I even trying to do. So even if I find the answer that way, it will just be a serendipity. Okay, anyway, bye bye everyone. So I'll do another question, I'll just start another video right away.